Alright, so today we'll be starting with this unit 12 of your class 12th part 2nd book, Aldehyde ketones and carboxylic acids. And today you might also get some disturbance because today it's raining here in Jaipur. So okay, chalo. Let us start with this chapter, which is your aldehyde ketones and carboxylic acids. So on this page they have told you what aldehyde ketones and your carbonyl compounds basically are. So the compounds which have your CO double bond, है ना? So organic compounds containing your CO double bond are known as your carbonyl compounds, है ना? So these are very versatile functional groups because the questions that can be asked, or we can say that the number of reactions that you can study from carbonyl compounds are huge, है ना? So there is a very vast majority of compounds where we can see these carbonyl groups. For example, even glucose, if you know the structure of glucose, we know that the structure of glucose is something like this, that it has this CHO group and then it has CHOH groups, the 4 CHOH groups, and then it has CH2OH. So this is the structure of your glucose even. So here also you can see that the CHO group or your aldehyde group is present, है ना? Your aldehyde group is present. Even in fructose we know that in fructose we have C double bond O group or ketone group. So these aldehyde ketones, their carboxylic acids and all these are very versatile functional groups, and we are all surrounded by it. Okay. Now they have shown you the structure of your aldehyde, your ketone, carboxylic acid, and then your some acyl halide and acid anhydride. We all know this, but we must now understand one thing, that aldehyde and ketones, they are kind of different in the type of reactions that they show. Okay, usually aldehyde and ketones undergo addition reaction. So this, if you do not know, do not worry, I'll be telling you about all this, but I'm just saying that aldehyde and ketones have kind of different reactivity as compared to your acid derivatives. So what are acid derivatives? Acid derivatives are your first of all your acyl chloride, है ना? This is a acid derivative, acyl chloride. Okay, then you have your ester group, है ना? You have your ester group. Ester group is also a different is also an acid derivative. Okay, then we have your anhydride, OC double bond OR, है ना? So this is also an acid derivative, your anhydride. Then you have your amides as well, RC double bond O NH2. Even RC triple bond N, this is what? This is a nitrile group, है ना? This is your nitrile group, and then you also have your amides. So all of these are actually known as carboxylic acid derivatives. These are carboxylic acid derivatives. Okay, or we can say that these are derived from your carboxylic acid. So how they can be derived from carboxylic acid, this I will tell you further, but abhi, for the time being, you must remember that these aldehyde and ketones are chemically somewhat different as compared to your carboxylic acid derivatives. So in your carboxylic acid derivatives, except nitrile, the other four, they actually try to undergo addition elimination reaction. What is this addition reaction? What is this addition elimination reaction? This I will tell you. Okay, so don't worry about it. So the acyl chloride, ester, anhydride and amide, they actually show addition elimination, whereas your nitrile group does not react that way, है ना? What will be the reactions of nitrile? This I will tell you further. Okay, now let us try to move further. Okay, so here they have given you the structure of ester and amide, which we already know, we have already drawn it. Now you must also remember the structures of this vanillin, salicylaldehyde and your cinnamaldehyde. Why these are important? Because these structures can be given to you directly, है ना? So they can say that okay, I have vanillin, I have to, so they can ask in the question ki I have vanillin and I react that with your HI, है ना? So what will happen? Or HI, I know that HI can cause the cleavage of this OCH3 group, है ना? This is an ester, so it can cleave that compound. So then you have to know what is the structure of vanillin, and they can ask you what will be the product form. So you must know what is the structure of vanillin, only then will you be able to understand what you have to do in the reaction. Suppose they give you vanillin and then they say that I have to reduce it with zinc amalgam and HCl. So you know that zinc amalgam and HCl can actually reduce this. It is Clemmensen reduction. So Clemmensen reduction will reduce the CHO group. Now if you do not know the structure of vanillin, then you won't be able to solve this easy question. Okay, so try to remember the structure of vanillin. Similarly, try to remember the structure of salicylic. So remembering salicylic is very important, because in the previous chapter only we have read your Kolbe's reaction. Okay, so we read in Kolbe's reaction we make salicylic acid. What is salicylic acid? How is it made? We take phenol and then we make it react with CO2. है ना? We make it react with CO2 and the product formed is salicylic acid. Is salicylic acid, CO2H, है ना? Now instead of CO2H, if I have CHO, है ना, if I have aldehyde group, then the compound will not be called salicylic acid, it will be called salicylic. Salicylic acid, this is salicylic acid, whereas your salicylic is what? Your salicylic is this, C double bond OH and your OH. Okay, this is known as your salicylic. Okay, so this is how you can remember salicylic. Okay, now let us try to remember the structure of cinnamoldehyde. Now cinnamoldehyde is very important, है ना? One of the questions that it can ask you, if you have already studied aldol condensation, then you can watch this part. If you have not read aldol condensation, as I have not told you, but I think most of you would be knowing aldol condensation. If you don't know, then wait for some time. I will be teaching it on this channel itself. So abhi it will be covered in this chapter only. Okay, so suppose I am given the cinnamoldehyde, and if I ask you ki how cinnamoldehyde can be formed from aldol synthesis, then how can you do it? Suppose I have this compound. So if I ask you ki suppose I have the product, my product is cinnamoldehyde, what would be the reactants, है ना, for them, for which aldol condensation would give me cinnamoldehyde? So if I take this compound C double bond OH and I cause the aldol condensation with this compound, है ना, then the product would be cinnamoldehyde. Now how does this happen, है ना? We know that this has your alpha hydrogen, है ना, whereas alpha hydrogen is missing in this benzaldehyde, no alpha hydrogen, whereas in acetaldehyde you have 3 alpha hydrogen. So what you can do is that you can remove water, because it is a condensation reaction. We know that water will be removed. Now what is the mechanism, that I am not going to tell. That this proton will first abstract it, your enolate will be formed, that enolate will add to your aldehyde. We will be keeping it for further discussion. But if you know aldol condensation already, you know ki bhaiya what we have to do is that we have to remove this remove these two water molecules and this remove these two hydrogen and this oxygen, so that water molecule is released. And once water molecule is released, what will happen? It will lead to the condensation of the two compounds, and the product form would be something like this. This is your benzene ring, this is your CH double bond CH CHO, है ना? So we can also say that this is an alpha beta unsaturated carbonyl. If we know what alpha beta positions are, I have not told you yet, but I am saying that if you know aldehyde, if you know aldol condensation, then this would be a kind of a new way of seeing cinnamoldehyde, है ना? So instead of remembering the structure of cinnamoldehyde, you should remember it as कि भैया if I condense benzaldehyde and acetaldehyde, I will get cinnamoldehyde. Now I know aldol condensation, I will do the condensation and then I will know what the product is. Okay, so this is how you can remember the structure of cinnamoldehyde. Okay, now let us try to move further, which is the nomenclature and structure of carbonyl group. So this is very easy part. Here one of the things that you have to remember is some of the common names. You know what acetaldehyde is? Abhi I have already told you कि acetaldehyde and benzaldehyde, if I condense both of them, है ना, what will it give me? It will give me cinnamoldehyde. It will give me cinnamoldehyde. Okay, now what they have also tried to tell you is that the carbon which is next to this C double bond OH group, है ना, or the carbon that is attached to your carbonyl carbon atom is termed as alpha, है ना, alpha, beta, gamma, and then comes delta also, है ना. So this is delta. So this is what they have told you here कि भैया the carbon that is attached to C double bond OH is known as alpha, next carbon is known as beta, next carbon is known as gamma, and the next carbon, if it would have been present, then it would have been called delta. Okay, so this much you have to remember here. Okay, now let us try. So it is not very tough to read all of this. Whatever they have told you in that paragraph, that I am telling you in a simplified manner. Okay, so no need to just read all of that. Okay, so here they have shown you some of these structures. These are also very important: acetone, acetophenone, propiophenone, and your benzophenone. So why these structures are important? Because these benzophenone and all, they can be given you for your electrophilic aromatic substitution, or they can say, bhai, I have benzophenone and then I treat it with zinc amalgam HCl, what will be the product formed? So many questions can be framed from these structures. Okay, So they just have to, instead of giving you the structure itself, they just have to give you the name, and then they will write some of the scheme ki bhaiya, suppose let us try to make a question. Okay, so suppose I say ki bhaiya, I am the examiner and I want to make a question. So I will write benzophenone, and then I'll ask ki, okay, let me do zinc amalgam and HCl. Some product A is formed, and then I treat it with HNO3 and H2SO4, and some product B is formed, and then what I do is that I again treat it with zinc amalgam HCl. Okay, so what will be the product formed? So what will be the different products? We know कि benzophenone when treated with zinc amalgam HCl will reduce the C double bond O group. Okay, so this C double bond O group is reduced and you get this compound. Okay, now they are saying that you have to treat this compound, this is your A compound, you have to treat this A compound with HNO3 and H2SO4. We know that this is the reagent that we use for nitration. So once we will do nitration, we know that nitration will occur at para position. Okay, so because the ring is activated, है ना, you can do it on any ring because both the rings are symmetrical. Okay, suppose I do it on this ring, you do nitration only once, and then what it is saying that you have to treat this with zinc amalgam and HCl. Now if you do not remember, zinc amalgam HCl is not just reducing agent for C double bond O group, it also converts nitro group to NH2 group, है ना. It can also be used to reduce your nitro group. So what will happen, your nitro group will be reduced and the product that would be formed would be this one. Now many student might get confused, they might say ki bhai, now in B we do not have any C double bond O group, so where will this zinc amalgam HCl attack, है ना. So they start questioning what the structure of benzophenone is, है ना. Even they would know what the structure of benzophenone is, है ना, but still because in conversion of B to C they have given you zinc amalgam HCl, you would try to question yourself कि भैया benzophenone का structure यही है या कुछ और है कि नहीं. So you must understand that remembering a structure is very important, at least those structures which are given in NCERT. I'm not asking you to remember all of these structures, but those structures which are given in NCERT, they are very important. Okay, chalo. Now we all know some these Iupac nomenclature. Let us try to quickly go through some of them. This is your ethanol. We know what ethanol is. Then this is your 4-bromo 3-methyl heptanol. So as we know that aldehyde is a terminal functional group, so we have to start numbering from this one: 1, 2, 3, 4, 5, 6, and your 7. Okay, so we have seen that we have 4 pe bromo, then we have 3 pe methyl. So why 4 bromo is written first? 4 bromo is written first because bromo B comes alphabetically prior to M, है ना. So that is why we have written 4 bromo 3 methyl heptanol instead of 3 methyl 4 bromo heptanol. Okay. Now next we have 3-methylcyclopentanol. We know that in cyclic structure we will give first priority to this, so this will methyl carbon will be third. So we know that third position pe we have methyl, and then we have cyclopentanone, sorry. Okay, so now they have also given you structure of pent to enol, है ना. Now if I ask you कि how do we synthesize pent to enol, है ना, so your answer would be what? Your answer would be aldol condensation, ठीक है ना. We know that this is alpha and this is your beta. So what is the product of aldol condensation? The product of aldol condensation is alpha beta unsaturated carbonyl compound, है ना. So this is what? This is alpha beta unsaturated carbonyl. So now if I ask you कि भाई how can you form pent to enol, है ना, from aldol condensation, what would be your initial precursors that you would use? So the initial reactants that you would use would be CH3 CH2 C double bond OH. Okay, first would be this, and your second compound would be CH3 C double bond OH. So what you would do, you would treat them with KOH, and what would happen is that this you would form as enolate, and then you will remove water molecule from this. Okay, once water molecule is removed, what will happen that these two compounds will get attached, CH3 CH2 CH double bond CH C double bond OH, which is pent to enol. Now some of the students, they also might get a doubt कि why did we abstract hydrogen from this, why did we make enolate of this? So this you would only understand if you know aldol condensation. If you do not know aldol, just skip this lecture to some time further. Okay, now why we are making enolate from this only, not from this one? So here we can make all the various possibilities, है ना. Instead of drawing all those possibilities, I am just telling you कि भैया how I can form this compound. Of course there are more possibilities present, but what I have done, I have taken this compound separately, I treated it with KOH. So if I treat this compound separately with KOH, what will happen? Then there is self aldol condensation can take place, है ना? But what I am doing is that once I make this first, then I add this. Okay, so what will happen? I can get my desired product. Of course, there are more than one possibilities for reaction to occur here. But what I am doing, I am telling you how pent-2-enol can be formed. I am only specifically concerned with pent-2-enol. I am not concerned with all of the other possibilities. Okay, so this is what we have to remember here. So how you can remember the structure? Okay, so pent-2-enol is very easy. You will be able to remember that, है ना? You would have had problem in cinnamaldehyde. So I have told you how to remember the structure of cinnamaldehyde. You do not have to remember the structure of cinnamaldehyde. You have to remember कि भाई cinnamaldehyde is the aldol condensation product of your benzaldehyde and your acetaldehyde. Okay. Similarly, you get this compound 3-oxopentenyl. So why these compounds are very important? This dicarbonyl compound, your beta dicarbonyl compounds. So if you remember, you study this kind of structures in your tautomerism, है ना? So in tautomerism we say कि भाई structures which have alpha beta structures which have beta dicarbonyl compound, they have their percentage enol content usually very high. Okay, so what will happen is that it can undergo this kind of so it can undergo this tautomerism, and what can happen is that it can form hydrogen bonding with this, है ना? So as it leads to hydrogen bonding, है ना, we can say that this enol structure is very stable, and we know that for beta dicarbonyl compound, this compound is known as beta dicarbonyl compound, है ना? We know that for beta dicarbonyl compounds, percentage enol content is more than percentage keto content. Okay, so we know here that percentage enol is more than percentage keto. Okay, this you should remember for this structure. Okay, so 2,4 dimethyl pentane 3-on, this you can draw. Then you can also draw this one, and you can also draw your 4-nitrobenzene carbonaldehyde. Okay, now let us try to move further on this table. So on this table there are not many important points, but I would like to focus on some of the important structures. Okay, so you must know the common name, because you know Iupac name तो you can do, है ना? Iupac nomenclature you have studied, so you can do that. Try to focus on these common names like phthalaldehyde, है ना? So phthalaldehyde is very important, है ना? Suppose I give you, so how can you remember phthalaldehyde? If you know the structure of phthalic acid. What is phthalic acid? What is phthalic acid? Phthalic acid is this one. This is phthalic acid. Okay, and we also know a very important reaction of this. If you have completed your 12th, then you would remember. If you have not completed your 12th and you're reading it for the first time, then this might cause problem for you. You might not know this, but we will cover it subsequently. Suppose I heat it, so what will happen is that it will lead to loss of water. So once it will lose water molecule, what will happen that it will join, and it will lead to the formation of this phthalic anhydride. So what is this known as? This is known as phthalic acid. This is known as your phthalic acid. What is this known as? This is known as your phthalic anhydride. This is known as your phthalic anhydride. Okay, so these structures are very important. So if you know the structure of phthalic acid, you would also know the structure of phthalaldehyde. ठीक है ना? You just replace that acid with CHO group. Okay, what will form? Your phthalic acid would be formed. Okay, chalo. Now here I would also like to focus on one structure which is Mesetal Oxide, है ना? So now if I ask you कि भाई how Mesetal Oxide is formed, so what is Mesetal Oxide? Mesetal Oxide is this one. And then you have your carbon which is double bonded to this CH, which is connected to C double bond to CH3, है ना? So instead of drawing this CH, I can what I can do is that I can delete this and I can join this, है ना? This is your structure. This I have to form, है ना? So this is the structure of Mesetal Oxide. This is your structure of Mesetal Oxide. Now if examiner gives you कि भाई I have Mesetal Oxide and then I treat it with this, so how can it be treated? So if you have completed your 12th, you would know that so why I am telling you all this, why I am trying to connect it, because there are many students who are going to see this, है ना? I don't know what level of preparation you are currently on, है ना. Either you are a dropper student or you are a fresher student. If you are a fresher, you can skip all these parts. But if you are a dropper and you do not see these points, then there is no sense of reading NCERT. Okay, because you must be able to connect the dots. Okay, so this is what they do in the exam. They try to connect the dots. They want to know that you have this conceptual clarity in your mind or not. है ना. So what they can do is they can give you they can say that okay, now let us try to frame a question. Instead of drawing this, let us try to frame a question. Suppose they give you कि भाई I have mesetal oxide, because the structure is given in NCERT, so it is highly probable that they will ask you. So this is mesetal oxide and they say कि भैया I have treated it with RMGX, है ना. What is the product found, है ना, and then you are given the options and then they have shown you the structure. Now if you do not know mesetal oxide, then you are doomed, है ना. Why? Because it is very easy. This reaction is very easy. So you must know the structure of mesetal oxide. So what mesetal oxide actually looks like? It looks like this, है ना. So what will happen is we know that if it will react with RMGX, this RMGX is a Grignard reagent. Grignard reagent can undergo 1,2 addition, है ना. In case of alpha beta unsaturated carbonyl, you would know this if you are a class 12 student or if you have completed your class 12th. So this would be your structure form. This you would know, है ना. How you would know this? You would know this only and only if you knew the structure of mesetal oxide. Now if I give you mesetal oxide to learn कि भैया learn this structure, you might forget it. Let's not try to remember it in this way. Let's try to remember it in a different way. So what will happen if I take two different molecules of acetone and I try to condense them, है ना. What I can do is that I can remove two hydrogen from here and I can remove this oxygen, है ना. If I remove them, what will happen? This molecule will get condensed. So once it will get condensed, what will happen? It will lead to the structure of this, which is your mesetal oxide. So instead of remembering or cramming the structure of mesetal oxide, you just remember this much कि mesetal oxide is nothing but just the aldol condensation product of two different acetone molecules. If you remember this much, then it is more than enough for you. Okay, so you will be able to remember mesetal oxide. Okay, chalo, let us try to move further. What is the structure of your carbonyl group? So this is very easy. We know that carbonyl compound in carbonyl compounds you have C double bond O groups, है ना. So when we have C double bond O groups, we know that delta positive end is on your carbon atom and delta negative end is on your oxygen atom. So we have these pi electrons. These pi electrons, they are loosely held, है ना, and they are more polarized towards the electronegative atom, which is your oxygen atom. Now we know that this carbon is sp2 hybridized. How we know that this is sp2 hybridized? For carbon containing compounds, we know that if we count the number of sigma bonds, it will give us the steric number. So how many sigma bonds are present? 1, 2, and this one your third carbon, this one is your third double bond, है ना. So sorry, third sigma bond. So if you have three sigma bonds, then 3 will be your steric number. 3 will be your steric number, and we know that for 3 steric number, what hybridization occurs? This hybridization is sp2. So we know that if the hybridization is sp2, then one of the p orbitals will remain unhybridized. So how will the structure do? The structure would look something like this. This is your p orbital, and we know that sp2 hybridized carbon atom is planar in nature. So these groups, these will be planar, and your p orbital, this p orbital would be perpendicular to your sp2 hybridized atom, sp2 hybrid orbitals. So this we know, है ना, this much we know that this is the structure of your carbonyl compound. So this is what they have shown here also. Okay, the carbon atom is sp2 hybridized from 3 sigma bond, है ना. Then we have the pi bond, and pi bond occurs between the overlap of your p orbital of oxygen atom, है ना. And then we know that 120 degree will be the bond angle. Why 120 degree would be your bond angle? Because we know कि भैया your sp2 hybridized carbon atom is trigonal planar and the bond angle becomes 120 degree, है ना. So it is trigonal coplanar structure. Then we also know that these are the two different resonating structures. Now if I ask you, okay, so if I ask you कि which, this is resonating structure A and this is resonating structure B, if I ask you which resonating structure is more stable, so we know that A resonating structure would be more stable. Why it would be more stable? Because it has more number of bonds. Suppose if B has X number of bonds or X number of क्या कहते हैं sigma bonds, then not sigma bond, I would not take this name sigma bond. If we have X number of bonds in structure B, then A has X plus 1 number of bonds, है ना, and we know that more the number of bonds, more stable is that resonating structure, है ना. Or we can also understand it in this way. Here we see this carbon atom. So this carbon atom is electron deficient here, है ना. How many electrons does it have? It has 2, 4 and then 6. It has only 6 electrons. Its octet is not complete. Whereas in A, the octet is complete, 2, 4, 6 and this is 8. Okay, so as in A, carbon atom has its octet complete, है ना. Why this octet is complete? This octet is complete because it has X plus 1 bonds. Okay, so you can say it in either way. You can say that the octet is complete, or you can say that it has X plus 1 bond. Both would eventually mean the same thing. Okay, so that is why A structure is more relatively stable as compared to B. Okay, carbonyl, we also know that the carbonyl carbon atom is electrophilic in nature. So this I have drawn here, है ना. We are seeing that it has delta positive charge, so hence it would be electrophilic in nature, or a nucleophile can attack on this carbon atom. Okay, and there is also substantial dipole moment. So what will be the direction of the dipole? It would be from positive to negative end, है ना. So what is the negative end? The oxygen atom is electronegative, so it is the negative end of the dipole. Hence the dipole would be from carbon to oxygen atom, है ना. And they are highly polar, है ना. They are more polar than your ethers. So this is also very important point, है ना. So it means that if it is more polar than ether, then definitely it would have more boiling point as compared to your ether, which I have already shown you in the previous chapter itself. Okay, this much you should remember.